8.2 Cause and Effect. So the goal here is to distinguish between correlation and causality and identifying types of relationships between variables. So data analysis involves more than just fitting a line or curve to a set of data points. Once you know there is a correlation, it is important to consider how and why such a correlation exists, to distinguish between correlation and causality. So data can show you there's a correlation, but you must be able to consider if there is a cause and effect relationship between the two variables. So there are different kinds of causal relationships. We're going to look at some of these together. So the first one we'll look at is direct cause and effect. So a simple definition for this, I could say, is that a change in the independent variable causes a change in the dependent variable. In other words, whatever X is what's causing Y to happen. So as an example, as the number of kilometers you drive in a car increases, then the amount of fuel you have left decreases. So X causes Y. Another example would be as production increases, or production speed increases, then the quantity of the items that you produce also increases. And just using arrows to signify the increase or decrease. So those are a couple of examples of a direct cause and effect. Common cause. So common cause is another kind of relationship, and we're going to say that this is an external third variable causes two variables to change. So this is kind of like saying Z causes X and Y. So if you were looking for the correlation between X and Y and you found one, there might not be a direct relationship between X and Y, but there could be a third common cause causing it. So it might be hard to think about with that one abstractly. So let me give you an example. So the example could be a positive, strong correlation, and let's say between two variables, X and Y, it's called, let's say, ice cream sales. And let's say drowning incidents. But you might wonder, well, yeah, there doesn't seem to be any causal effect between ice cream sales and drowning incidents. So, so if you say, well, the more ice cream sales you have, the more drowning incidents you have, how does that work? How does ice cream cause drowning? But if you think about it more deeply, there's a third variable, and that third variable would be temperature. So what's the common cause? It's going to be the warm weather. So common cause, warm weather causes an increase in both. So the hotter the weather, the more ice cream people buy. The hotter the weather, the more people end up going to swimming pools, and coincidentally, more incidents of drowning can happen. So that's common cause. The third one, reverse cause and effect. So this one is the independent and dependent variables are reversed. So how can I demonstrate that? Well, I can do this by showing you a hypothesis and a conclusion. So in my hypothesis, we could say coffee causes nervousness. But in a reverse cause and effect, this would be akin to saying nervousness, or nervous people tend to, or more likely to, drink coffee. So you may have started off with a claim saying coffee causes nervousness, but after you do your study, you found the relationship between the variables, and you might conclude that the reverse was true. Nervous people are more likely to drink coffee. The fourth kind is the accidental relationship, and this is just a coincidental relationship, correlation. So coincidental correlation. So an example could be the correlation between local kitten birth rate and declining school enrollment. So in a graph or in your data, you may find a correlation between these two variables, but there is nothing that suggests that one would cause the other. So it would just be coincidental. And then you have a presumed relationship, which is a relationship that makes sense, but you cannot see any common cause. But no common cause or any kind of effect is apparent. Okay, so what could that be? Maybe a correlation between self-esteem and vocabulary. The more self-esteem you have, maybe the more vocabulary level you have, how much diction you use in everyday speech. It could make sense, but there wouldn't be any particular common cause. Alright, let's look at a few examples here. So example 1, the scatter plot and the line of best fit show the relationship between the number of successful free throws made out of 10 attempts and the number of hours spent practicing for members of a basketball team. So here it is. Number of baskets, free throw attempts, and the number of hours spent practicing. And it looks like the data does have some kind of a correlation. There's a line of best fit through the data. It's reasonably strong. So if you notice the correlation coefficients, we need to find the correlations. How do we characterize the correlations? Just by looking at this number here, r squared. Now, correlation coefficient itself would be r, but usually in calculators we're calculating r squared, and r squared is more universal in the sense that it can be used not just for lines but for other kinds of shapes and curves and so forth. But for a line, correlation coefficient of r is what we're looking for. And to find r, you simply take the square root of r squared, so the square root of 0.78, and that would be 0.88. So it's a fairly strong correlation. So we say it's a positive. It's positive because the line is going up and to the right, and it's a strong correlation. So I think it's reasonable to suggest that this is a cause and effect relationship, since in general, the more you practice at almost everything, then the better that you get. So the more hours you practice, the more free throw shots that you can score. So it's a very reasonable cause and effect relationship. Interpret the line of best fit. Well, okay, so if you look at the line of best fit, the strong correlation suggests that it's a good model for predicting any values on this graph. So, I mean, it suggests that if you have no practice, and we've extended the line further down this way, if you have no practice, then a player is unlikely to make any shots into the basket. And the rate of change is of 1.22 suggests that with each hour of practice, then the number of successful free throws will increase by 1.2. So yeah, it's fairly reasonable to say that this is a good line of best fit. Right, discuss any limitations of this linear model. Well, the model suggests that with continual practice, it is possible to get more than 10 shots out of 10, right? So if you continue the line this way, it says, well, I can get now 12 shots if I did more than 10 hours of practice, which is impossible because the whole thing is a measurement of how many free throws can you make out of 10 attempts. So the maximum limit is 10. So there's a limitation that the graph cannot extend past a certain point, otherwise you're going beyond 10 shots. Okay, so example number 2, classify the relationships and justify your choice in each case. So patient's stress level is negatively correlated with the amount of exercise performed. So I'm going to say here this is a cause and effect. The reason why is because there have been scientific studies that have proven that exercise helps reduce stress. So if it's negatively correlated, it means your graph would look like this. So your stress level is going down as you increase the exercise. Student math scores are positively correlated with English scores. So I'm going to say this is maybe a common cause. Because first of all, it's hard to make any direct connection between math scores and English scores. Anything that you try and do would probably be very subjective. So there must be another common cause. So the third variable might be very strong study habits. So if you have strong study habits, then you're more likely to succeed in anything. So you'd succeed in both math and your English. And the resulting scores would go up. Pancake sales are negatively correlated with the amount of rainfall. Well, I would say this is completely accidental. I don't see a clear connection, so no clear connection. And part D, a job interview success rate is positively correlated with the number of years a person has been married. Well, job interview success rate and the number of years a person has been married. It could be accidental, could be a presumed relationship. You know, if you think about the logic behind it, it might make sense. You know, if you had a stable relationship in your marriage, then chances are you have maybe good communication skills, and that would translate into certain job interview success as well. Yeah, I mean, it's really difficult to really suggest a causal link or any kind of common cause, but we just have to say it's presumed. So presumed relationship. So that's just a review, an overview of the different kinds of cause and effect relationships that we study in this course.